Hello, sir.
Yes, Dr. Mustafa.
Thank you. All done, sir.
Yes, well done. Good morning.
Thank you. Good morning, all. On behalf of the Supreme Congress of ARD UDUTH, I welcome you all to the 2025 Research Methodology Workshop of ARD UDUTH. Today, we are in week 4, day 1. We welcome our teacher, Dr. Malami Bello, who helped teaching with so much it is a selection perfect formula for sample size calculations, sample size estimation, and sampling technique. You are highly welcome, sir.
Thank you very much, Dr. Mustafa. And also thank you all of us, all the audience and organizers of this program. Before we continue, I want to apologize for not coming last week. It was due to a problem beyond my capacity, because I had been here trying to join, but the internet couldn't allow me. But today, inshallah, we are going to take our lecture that we supposed to take last week. Today's discussion is one of the very best discussions or a component of methodology, and is very important because sample size determination and sampling technique is one of the most important aspects of the research. Once you have gotten your sample size wrong, it means everything you have done is wrong. So that's why sample size determination is very important and is key in every research. Once it is not gotten right, then everything is null and void in the research. Whatever you have gotten is not true and is wrong. Therefore, let's look at the sample size determination. And when we finish, if time permit, we will go on to continue with the sampling technique. So, okay, let me put it on the slideshow so that we yes, sample size determination. Sample size is the subpopulation to be studied in order to draw an inference from a reference population. We have, in our previous discussions, we have explained what is sampling, what is sample, and what is population. You know, population is the general population in which someone, a researcher, has an interest. For example, we say, let's say maybe a population of pregnant women that attend antenatal clinic at Usman Danford University Teaching Hospital as a whole. That is the whole, that is the population. But the sample, the participant that you have drawn out of these people in order to administer your questionnaire to, so that at the end of the day, you draw conclusion generally on the general population. So sample size is the subpopulation the subpopulation that you want to draw your participant, for which at the end of the day, you now generalize the result, whatever you have gotten, to the general population. Why? Because you cannot include everybody in the population. So because of that, you have to sample the representative of that population, so that whatever you have gotten, this sample that you have drawn is the representative of your population. And at the end of the day, you are going to use your result in order to generalize to the general population. In census, sample size is equal to the population size. But in research, because of the time constraint and the budget, a representative sample is normally used. So the larger the sample, the more accurate will be the findings from a population. Yes, but even if the sample should be large, once you use the right formula to calculate your sample size, so that sample size is optimal. Whatever you have gotten from your formula, if you have used the right formula, is the optimal sample size. Going above the optimal sample size may introduce some bias, and going below the optimal sample size may also introduce some bias. For example, if you are going above the sample size, you may introduce type 2 error. Type 2 error, you may find the result that is not there, the difference that may not be there. But because of the large sample size, you may find that difference significant when it is not significant in reality. That is the type 2 error. Another thing, if your sample size is very low, is very small, you can also introduce type 1 error. So the difference that is not there, you may not find the difference that's supposed to be there. If there is a difference in reality, but because your sample size is too small, you will fail to find that difference, and you conclude there is no difference when the reality says there is difference. So that is the importance of calculating an optimal sample size using the right formula and right method. So availability of resources set upper limit of the sample size, but nevertheless, because of all this, if you can study the general population, everybody in the population, so that is the most important. That is the main thing. If you can study everybody, but because of the constraint in the finances, the constraint in the manpower and other things, then we say you have to calculate the optimal sample size for which you are going to use in order to represent this population. So what are the approaches to sample size calculation? The approach to sample size calculation can be arrived by responding to the following set of questions. 1, what type of the study is this? So before you know the right formula you are going to use for calculating your sample size, you must answer these questions. Because if you answer the question wrong, you may end up using a wrong formula. So now, for you to get the right formula to use, you have to ask yourself and answer all these questions. 1, what type of the study is this? So you must know the type, the design of your study, because you are going to select your formula, the formula to be used based on the study design, based on the study type of your study. If your study is cross-sectional study, the formula is different for cross-sectional study. If your study is case control study, the formula for case control study is different. if even in the cross-sectional, maybe you are using the endpoint or the outcome, your outcome is in number, is a quantitative variable. So the formula for a quantitative variable outcome is different from the formula for qualitative outcome variable study. So that is why it is very important to understand all these things. You must know which type of study design you are dealing with first, before you even go and select the formula to be used. Then number two, single sample. You have to know that if it's your study, are you using one single sample, or you are using different samples? For example, is it that you are comparing two different samples, like rural and urban, or rural alone, or urban alone, or you are using control and study groups? So having two groups, the formula you are going to use in two groups is different from the formula you are going to use if your sample size is only one group. So you have to also note that and find the answer for that before you go on to select your formula. Number three, comparison of two groups. Are you comparing two groups, or three groups, or four groups, or you are only using one group? So you have a cross-sectional that is comparing two groups. That is a comparative cross-sectional study. When you want to do a cross-sectional, but among two groups, group one and group two. So the formula for that cross-sectional is different from the cross-sectional study formula, which you are using only one group. Then the formula for case control. You know, case control, you are comparing two groups, cases and control groups. So this type of study is also has a different formula from the single group study. Then cohort study. Cohort study is also a study that consists of comparing two groups. So in this case, the formula is also different. Then another thing, what is the main primary outcome? So when you know your study type, you know your sample, you know your grouping, comparison group, whether it's comparison group or not, you must also know your outcome variable. What is your outcome? Is your outcome quantitative? That is, it is measured in number, or your outcome is qualitative, measured in category. So the outcome that is measured in quantitative variable is like saying, maybe when you say blood pressure measurement. So you know blood pressure measurement is in number, either 120 over 80, anything like that. Then another one is the outcome of a particular maybe measurement, for example, PSA. Measurement of a PSA values, or measurement of protein in the body, measurement of PCV. So when you are presenting them in number, so that outcome is a quantitative outcome. It means you are measuring them, you are reporting your outcome in terms of mean and standard deviation. So you have to note that. And also another thing that you should note is that, is this your outcome a categorical variable? That is, even if it is quantitative, are you reporting it in category? Like maybe you have measured your outcome in number like PCV, but you want to report it in category, whether somebody is having anemia or not. That is anemic or not anemic. That is, in this case, you have categorized it. You have categorized the values into categorical variables, whether anemic or non-anemic. So if you are reporting your result, your outcome In categorical aspect, then you are going to use a categorical formula for that. But if you are reporting your outcome in terms of mean and standard deviation, not in category, you are reporting it without categorizing it. You just want to report the mean PCV. Maybe the mean PCV is 35.3%. So that is in number. So in that case, you are going to use a quantitative formula for that. So then, what is the expected variability between the subjects? If the expected, you have to also know what is the variability, the difference between the subjects that you are expecting. In case of if you are comparing two groups, maybe you want to compare those that have used something from those that have not used. What is your expected difference that you think that difference may be a significant difference? You have to also put into consideration that aspect for you to use the right formula in calculating your sample size. So, nevertheless, these are the most important questions that one must answer before choosing his right formula for sample size calculation or estimation. So now, sample size determination is the mathematical estimation of the number of subjects or units to be included in a study. So we have said we calculate the sample size because of what? Because we want to select the representative of our sample, of our population, I mean. So because we cannot include everybody in the population, we have to now select the representative of that population and determine the mathematical estimation. So determining the process of determining the mathematical estimation of the number of subjects to be included in that study is called sample size determination. When a representative sample is taken from a population, the findings are generalized to the population. But mind you, if you didn't select the right sample, then the generalizability is not possible. Because the sample is selected as a representative of the population. But when you now select your sample in your own way, without using a scientific method, without giving everybody in that population the chance of being selected, then you are not selecting the representative of that population. So the generalizability of that study is questioned, cannot be achieved. So we can say that study does not have what? External validity. You cannot generalize that population, that's the study, that findings in the general population, because your sample is not a representative of that population. So you cannot generalize it to the general population. But if you get you use the right formula, the right method of selecting your sample size, then you can make a general, you can generalize your findings to the whole population, and that is possible and that is valid. It means your study has an external validity. So the optimum sample size determination is required for the following reasons. One, to allow for appropriate analysis, to provide the desired level of accuracy, and to allow validity of significance tests. So now let's look at these issues. If the sample size is too small, I've already discussed it before. If the sample size is too small, Sorry, in my last explanation, I said if it is small, we introduce type 1 error. No, it's type 2 error that we introduce if it is too small. But if it is too large, we introduce type 1 error. So if the sample size is too small, even a well-conducted study may fail to answer its research questions. Yes, I have explained it earlier. So because if the sample size is too small, you may not have enough participants to measure your difference, to measure the difference that you are finding, the difference that you want to find, because the sample is too small. Maybe had it been that you included many people in the study, so many problems will be found. So as a result, you will be able to measure the difference when the difference is there. But because the sample is too small, you don't have enough people that will contribute to the measurement of this problem. You now conclude that the problem is not there, when in reality the problem is there. So this may lead to type 2 error. Another thing, if the sample size is too large, the study will be difficult and costly, and much time will be wasted in that study. So the problem getting enough cases is also there. For example, rare diseases. There are rare diseases, so you have a problem in getting enough cases in that type of study. Loss of accuracy. Hence, optimal sample size must be determined before the commencement of a study. So therefore, you see, because of all these issues, so you need to find an optimal sample size, which you use your formula to calculate. What are the factors that influence sample size calculation? Initially, I have outlined some questions that you need to answer before you select your formula for sample size calculation. So these factors that influence sample size is also related to those questions. Once you are able to answer those questions, then this one will be very easy for you. It's like you have taken care of all these factors. One is research design. We have earlier said you must know your research design. Are you dealing with cross-sectional study alone, or you are dealing with comparative study? Is the experimental study you are dealing with, or non-experimental study? Whichever type of study that you are using can affect or can influence the calculation of your sample size. Because if you are using a cross-sectional study and you go ahead to use the formula for case control study, then whatever you get is not a true representation of your sample, and that can affect the generalizability of your study, can affect the quality of your data, can affect everything in that study. So that is why you have to you have to be careful of what you are using in selecting the formula. Number two, the outcome. You have to make sure that you know the outcome of your study. What is the outcome? What is the anticipated outcome of your research? Maybe, for example, maybe the outcome is for this study is to know the knowledge, the level of knowledge. And the level of knowledge, I want to present it in terms of category, whether it is good or poor. So you see, in this case, my outcome is qualitative. I can also choose to say the outcome of my study will be level of knowledge, but in score, mean knowledge score. What is the mean knowledge score of this participant? I want to present it in terms of mean and standard deviation. so that the mean knowledge score for this research is 25.5 plus or minus 3.4. So you see, I'm presenting it in form of quantitative variable, not a qualitative variable. So if that is a case, my formula will be different from the one I will present in terms of good or poor, which is in category. I hope we are understanding this. So you must know the outcome of your research. Number two, type 1 error. Type 1 error can affect the sample size calculation. And what is type 1 error? Type 1 error is an error that occurs when a true null hypothesis is rejected. So the probability of making type 1 error is referred to as level of significance and is often considered as 5%, which is denoted by P 0.05. So this confidence level that we are stating during our sample size determination is very important, because this is saying that we are given the probability of making type 1 error in this research. The probability that we are allowing is only 5% probability. So almost everything, 95% of our findings, we are 95% sure our findings are accurate and correct. It's only 5% that may be due to chance. So that is our level of significance. So this p-value that we are saying, the p-value 0.05, this is what it means. We are saying that we are only given 5% chance of having an error in this study. So if you give 5% chance, it's different from the person that will give 10% chance of making error, and it's different from the person that will allow only 1% chance of making error. So now your level of significance is the one that you are the person that will choose it yourself. You can say I'm allowing 5% error. I can also choose to use 1% error to take my p-value to 0.01 instead of 0.05. But the most widely used p level of significance is 0.05. That is 5% chance. So it means you are 95% confidence that whatever result you will get in this research is true. It's a true measurement of that population. And you are only giving 5% chance of making an error, making a type 1 error. So this is our type 1 error. Then the corresponding p-value will be, the corresponding value of z will be equal to 1.96. So when you are using p-value of 0.05, that is 5% confidence interval, or 5% level of significance, then your z will be equal to 1.96. The z in the formula will be equal to 1.96. You know, you have been seeing z in all the formula for sample size calculation. So this z is dependent on the level of significance. If your level of significance is 10%, then your z will change from 1.96 to another value. If your level of level of significance is 0.1 or 1%, then your z value will also change from 1.96 to another value. So we are using 1.96 as our z value because our level of confidence, our level of significance is 5%. That is 0.05. So that is why we now we include this type 1 error as one of the causes or one of the factors that influence sample size calculation. because we are using Z in sample size, and this Z is dependent on type 1 error, or probability of making a type 1 error. Another factor is what? Type 2 error. What is type 2 error? Type 2 error is an error that occurs when a false null hypothesis is not rejected. That means your null hypothesis supposed to be rejected, but you fail to reject it due to some errors that you have gone through during your research processes. So when you do that, you commit a type 2 error. This means that the test is not able to detect the difference when the difference is actually there. That is why I said using a very small sample size can lead to type 2 error. Because when you use a very small sample size, there may be a difference, but because you have not included many people in that research, that difference will not be found, because many people have not been included. The only small people that you have included in your research may not be enough to find that difference. So in that case, you have introduced type 2 error. So the probability of the probability that the test will correctly identify a significant difference or a significant effect or a significant association, or should that association exist in the population, is called the power of the study. So your study, the power of your study is, for example, if the study is able to measure the association, well, if that association exists in that population, then your study is said to have the power, a very good power. It had the power to measure whatever the difference that is there, whether the difference is very small or the difference is very large. Your study is able to measure that difference. Then your study is said to have the power. So that is what we call power of the study. And power of the study is equal to 1 minus type 2 error. 1 minus type 2 error. And this power of the study is used in your formula for sample size calculation. So in most study, the power that we are using as our study is 80% power. So we are giving 80% power. We have given our study 80% power that this study will detect whatever the difference that is there in the population. We are 80% sure. So this 80%, this beta, that is what we are using in our sample size formula. You are seeing beta, alpha, and beta. So that beta that we are seeing in the sample size formula is using this power of the study. So mostly the power of the study we are saying is 80%. So it means when you say 100, 1 minus beta, if you say 1 is 100%, 100% minus power, which is 80%, will give us 20%. So if we are using p-value of 0.2, then our power will be equal to 0.84. So most of the study, we are using 0.84 as our beta. So that beta is due because we are using 80% power. If we are using 90% power, it means our beta will change from 0.84 to another value. So that is the effect. That is where type 2 error affects sample size calculation. Another issue or another factor that can affect the calculation of sample size is precision. I have explained the precision in the explanation of type 1 error. So the precision is the accuracy, the accuracy of your study, the accuracy of your study in finding the results. For example, you give only 5%, you said you are giving only 5% chance of making an error. So this precision, it means you are 95% sure the study is getting the right result. It means you are precise. The study is precise because it is using 95% confidence interval in detecting whatever it wants to detect. So that is precision. And that is what we use for sample size formula as our D. So that D, which we say D equal to 0.05, is our precision. That means we are saying we are allowing only 0.05 error in that study. So all these factors can influence the calculation of sample size. So you have to make sure that all these are identified and are used correct with the different formulae that we can apply for our sample size calculation. Number one, sample size calculation for cross-sectional studies. So now cross-sectional studies or cross-sectional survey are done to estimate a population parameter like prevalence of some disease in a community, or finding the average value of some quantitative variable in a population. So when we say cross-sectional studies are studies that you want to conduct in order to measure something. You just want to measure without comparing anything. You want to measure them, either you want to describe that measurement, or you want to find out what are the causes of that. What are the factors associated with such measurements? For example, in the population, we want to measure the prevalence of malaria and factors associated with this prevalence. So you are not introducing anything. You just want to go to the community, to the population, and then conduct a study among them without giving them anything, without comparing this group from this group, without doing anything, without introducing any intervention. So that is what we call cross-sectional study. You can also conduct an interval cross-sectional study or period cross-sectional study. Maybe people that has a certain problem between social period to social period. So it's also cross-sectional. You are only measuring their problem and describing it, and also finding out the associated factors with that problem. So that is cross-sectional study. So in these types of studies, how do you calculate your sample size? So now I've said you must know your cross-sectional study. You must know the type of study. So this is one of them, cross-sectional study. We said for a cross-sectional study. Then another issue, you must know the outcome of that study. What outcome are you going to measure? The outcome is of two types. It's either quantitative outcome or qualitative outcome. If your outcome is qualitative, that means you are going to present your outcome in terms of category, then this is the formula you are going to use. N is equal to Z alpha over 2 squared PQ all over D squared. And in summary, this formula is also summarized as Z alpha PQ square over D square, or ZPQ square over D square. That is the same formula. But this is the right description of the formula. that Z subscript 1 minus alpha over 2 square, then PQ all over D square. So this formula is also written as Z square PQ, Z square PQ over D square. It's the same formula. So what does this mean? N, small n is the minimum sample size. And also you have to know the size of your population. What is the size of your population? Is your population up to 10,000 or is less than 10,000? So in any case, if your population is the population of less than 10,000, you are going to still use this formula. And later on, you will now use a correction formula to correct the calculation, sample calculation. If your study population is greater than 10,000, so this is the only formula you are going to use in selecting the sample size. So usually, the hospital populations, they are usually less than 10,000. But the community studies, the studies that are conducted in the community are usually having the population of greater than 10,000. So whichever type of population you are dealing with, you have to use this formula if your sample size is cross-sectional, if your sample size, your design is cross-sectional, and you are dealing with qualitative variable. Then Z alpha, D1 minus alpha over 2 is the standard normal deviate at 5% type 1 error, which is 1.96. I have explained it when I was explaining the factors associated with, or factors that influence sample size determination. So this Z that we are using in that formula, this is the how to correctly write it. Z subscript 1 minus alpha over 2. That is your Z in the sample size formula. So this Z is equal to 1.996 if we are allowing 5% confidence level. But in case we are not allowing 5%, if we are only allowing 1%, then our 1.96 will be changed. It will not be 1.96. It will have another value. But I use 1.96 because most of our researches, we are using 5%. That is why I now come with the 5%. That is 1.96. Then P in the formula is the proportion or the prevalence of the factor under study or a pilot study, in previous study or in a pilot study. So now, if you are studying, let's say you are studying, you want to find the prevalence of malaria among pregnant women in UDUTH. So your P here will be the prevalence of malaria among pregnant women in previous study. That previous study can be in any state, can be in any country, can be also in Sokoto. So, but in previous study, if you have searched for previous study, you have not gotten any study that use proportion or prevalence of malaria, that conducted the study on prevalence of malaria among pregnant women. You can use the p-value in the prevalence in your pilot study. Maybe if you have conducted a pilot study for that study, you can use the p you have gotten in your pilot study. If you have not conducted a pilot study, then you use a p-value of 5%, 50%, I mean. You can use a p of 50%. Why? Because that p of 50% is the p that will give you the highest the highest number of sample size. So that is why it is said, if you didn't find a P in previous study, you didn't do the pilot study to calculate your P, you can just use 50% as your P. Because if you use 50%, you are going to get the highest number of sample size that is possible for that research. So that is why it is advisable to use 50% in case you have not gotten your P in after searching for any for all the study and you have not found any study that did a similar study with your study. Then Q. Q is the complementary probability of P. That is 1 minus P. Once you have your P, then Q, you just say Q will be 1 minus P. So if your P is 50%, then your Q will be 1 minus 50, which is also 50%. If your P is 90%, then your Q will be 100 minus 90 which will be equal to 10. So that is Q. Then D. D is the absolute precision. We have also explained it in the factors that are influencing sample size formula. So precision, that is the type or the proportion of error that you allow in that study. Because not any study can be 100% accurate. Any study must be prone to some errors. So in this case, you are only given 5% chance of making error. So that is your precision. So you are 95% precise in your study. So that is the formula for calculating sample size in cross-sectional study for a qualitative outcome. So what of quantitative outcome? Still cross-sectional study, but quantitative outcome. So for quantitative outcome, this is the formula that is going to be used. Z alpha standard deviation squared all over D squared. So this Z is Z subscript 1 minus alpha over 2 squared, then standard deviation, lambda squared, that is standard deviation of the outcome. Then D, we will also explain all of them. So our M here is the minimum sample size for the population greater than 10,000. But as I have said earlier, even if your population is less than 10,000, you must use this formula first before you now use the correction formula for populations that are less than 10,000. So now, if your outcome is quantitative, that means you are going to present your outcome in terms of quantity, not in category. As I have said earlier, maybe in terms of mean and standard deviation. Maybe your outcome, you want to state it in terms of mean and standard deviation. Then this formula is the formula that you are going to use. N will be equal to Z squared lambda square all over D square. So lambda is the standard deviation of the variable under study, or in previous study or through pilot study. So here, if you are going to maybe present your outcome in terms of mean knowledge plus or minus standard deviation. So your lambda will be equal to the standard deviation of the knowledge in previous study, in previous similar study. If you didn't get the previous similar study, you can conduct a pilot study and use that standard deviation. If you cannot do that, then Here we cannot say use 50% because this is not percentage. So it's better if you didn't get any previous study, then you conduct a pilot study and use that standard deviation in your pilot study. Then D is the absolute error or a precision, which is usually 0.05 as in previous formula. So now let's look at comparative cross-sectional study. So the cross-sectional study we have just discussed is this cross-sectional study for single group. Now, if you want to conduct a comparative cross-sectional study, maybe a cross-sectional study, but among two different groups, and you want to compare these groups. For example, you want to conduct a cross-sectional study between rural and urban population. So you see, you want to know the difference between rural and urban, but a cross-sectional study. So that is what we call comparative cross-sectional study. You can also conduct a cross-sectional study among two different patients. Maybe disease patient with, you want to know the difference between patients on so-so-so problem and patient with so-so-so problem. You want to compare one measurement or one outcome between the two. So this is also a comparative cross-sectional study. So what is the formula? If you want to use comparative cross-sectional study and qualitative variable, maybe you want to compare the prevalence of hypertension between rural and urban populations. So what is the prevalence of hypertension between rural and urban population? So that is a comparative cross-sectional study. And this is the formula because the prevalence of hypertension is either yes or no. So that is a qualitative outcome. So it's in category. So you are going to use this formula because your outcome is in category. N is equal to Z alpha plus Z beta all squared times P1 Q1 plus P2 Q2 all over P1 minus P2 squared. So this is the formula for comparative cross-sectional and qualitative variable. So here we say our Z alpha is what? Standard deviates corresponding to the required level of significance, which is 0.05 and is equal to 1.96, as I have explained earlier. Z beta is the standard normal deviate corresponding to required power of the test, which is equal to 0.84, as we have explained earlier. Then P1 is the prevalence of outcome of interest among the first group from a previous study. So now if we want to compare rural and urban, the prevalence of hypertension between urban and rural population. So our P1 will be prevalence of hypertension among rural community or rural population in previous study. Then P2, the prevalence of hypertension among urban population in previous study. So you see P1 is for your group 1. P2 is for your group 2, all in previous study. Then now Q1 and Q2 dissenting. Q1 is the complementary probability of P1. Q2 is the complementary probability of P2. So Q1 is equal to 1 minus P1. Q2 is equal to 1 minus P2. So when you have all those things, you will be able to calculate your sample size. And D is always the precision, your precision, which is 0.05. That is 95% confidence interval. So that is formula for comparative cross-sectional study with the outcome categorical, with the categorical outcome. Then what of comparative cross-sectional study with quantitative variable or with quantitative outcome? So if your outcome is quantitative and you are conducting a comparative cross-sectional study, then this is your formula. N is equal to Z alpha plus Z beta squared times lambda squared all over D squared, where Z alpha, we said, if the standard normal deviate corresponding to your level of significance, which is 5% or 0.05, and is equal to 1.96. Then Z beta is the standard normal deviate corresponding to our required power, which is 80% power, and is equal to 0.84. Lambda is the standard deviation of the variable under study in a previous study among similar subjects. So please note that the higher of the two groups is used. So in this case, maybe you want to compare the mean knowledge of hypertension, between rural and urban population. So you are going to select one standard deviation from a previous study. So which one are you going to use? Is it that of the rural or that of the urban? Which one are you going to use? So the one that you are going to use is the one with the highest value, the one that is higher. So now you are going to, maybe if you find the standard deviation among group 1 is 90, while standard deviation in group 2 is 40, then you are going to use the standard deviation of group 1, which is 90, because it is higher than 40 for group 2. So that is how you select your standard deviation between the two groups. So anyone that is higher is the one that you are going to use. Then D is the minimum difference that's considered to be significant. Now, here you are not going to use 5% precision for this type of formula. In this case, you are going to use the difference that are considered significant. For example, you want to measure the knowledge, the mean knowledge between rural and urban population, the mean knowledge of hypertension. So maybe you think, based on what you are seeing in previous study, 10% difference is a significant difference. Then you can use D as your 10%, because 10 is, or no, 10, not in percentage, 10, maybe the knowledge score is in number. So you are going to use, for example, 20, 30, 50, 40. So if you think a difference of 10-fold is significant, then you use 10 as your D. If you also think 5-fold, the difference of 5-fold between the two groups may be a significant based on what you have seen in the previous study. Then you use 5 as your D. So this time, this part is based on your own observation. Which number or which value do you think is the difference may be a significant between the two groups? You are the one that will find it and use it yourself. So another study design, sample size calculation for case control study. So what is case control study? Briefly, case control study is a type of study that is done between cases and control. But we make sure that the cases and control are matched. You have to match each other. In selecting your control, you have to match with the cases. So the case control study is the study that is done after selecting a case. So let me briefly explain how to conduct a case control study. So a case control, because why I said let me explain this, most of the studies that we are calling case control study, most of them are not case control study. Rather, they are comparative cross-sectional studies. Because a case control study must have 4 steps. It has 4 steps. Number 1, step 1 is selection of cases. In case control study, you must, and it is said the cases are usually rare. It is conducted among rare cases. Case control study is not usually conducted among the common cases like malaria, like all these common diseases. They are not good for case control studies. So it is usually done among the rare cases. So the first step in conducting a case control study is selection of cases. So you are selecting cases first. So for example, you want to conduct a study, and a study that says lung cancer, cigarette smoking can be associated with the development of lung cancer. So you want to conduct a case control study to test for this issue. So the first thing that you do is to select all the cases of lung cancer first. So when you select all the cases, so you see, you want to test whether cigarette smoking can cause lung cancer, but you are not selecting your cases on whether they are smoking cigarette or not, or no. You are not selecting your cases based on exposure, based on whether you are they are exposed to the exposure you want to test or not. No, rather you want to select them on the basis of cases, whether they are case or not. That is the only you are after, what you are after of. Are they a case or not? So just go to the, maybe where you want to select. You can use hospital cases, you can use general population cases. So just find your cases of lung cancer. When you select your cases, then step 2 is selection of what? Selection of controls. So now in this case, you also select your control on the basis of having not having lung cancer, not on the basis of whether they smoke or not smoke. The only thing you use in selecting your control, do they have lung cancer or not? Then you now select them. Then number 3 is matching. Step 3 is matching. You have to match your cases with controls. If you have a case that is male, 25-year-old, you should have a control for that case as male, 25-year-old, or very close to that, so that you match them. So all the cases will be matched for age and sex and all the other qualities that may affect the result of the research. So when you finish matching, the next thing is what? Measurement of the factor under study. The factor under study here is cigarette smoking. You now ask all the cases about their history of cigarette smoking, and also ask all the controls about their history of cigarette smoking. So when you finish, you have gotten all your data from the cases and controls. The next thing is analysis. You analyze your data. Among the cases, how many of them have smoked cigarettes and developed disease? How many cases how many cases have not smoked cigarettes, but they are still cases? Then among the control, how many of them are smoking cigarettes, but they don't have the disease? How many cases are not smoking cigarette and they also do not have the disease? Then you now use that and calculate your odd ratio. So it is using this odd ratio that will now tell you whether cigarette smoking is the real cause, can cause or can be associated with the development of lung cancer. So that is a case control study. So we say it is usually conducted among what? For the diseases that are rare. So if your disease is so common, then it is not appropriate for case control study. So another issue is so this is the formula for case control study if the outcome is qualitative outcome. So the qualitative outcome, for qualitative outcome, the minimum sample size is equal to N is equal to R plus 1 over R times Z alpha plus Z beta squared times P bar into 1 minus P bar all over 1 P1 minus P naught squared, all squared, where Z alpha is as stated below, as stated previously. That beta is the same as in previous, that alpha and that beta, they are all the same as previous formulae. Then P naught is the prevalence of exposure of interest among controls from a previous study. So the prevalence of exposure of interest, that is prevalence of, because exposure of interest here, let's say in from our example, the exposure of interest is what? Is cigarette smoking. So P naught is the prevalence of cigarette smoking among controls from a previous study. How many of the controls in previous study were smoking? If they were 10%, then our P naught will be equal to 10%. Then P1 is the prevalence of exposure of interest among cases in previous study. So, and this one is calculated using this formula. P1 is equal to P naught times odd ratio all over 1 plus P naught times odd ratio minus 1. This one from the previous study. So our odd ratio, you will see the odd ratio in the previous study that you are using. So once you have your P naught and you have your odd ratio, then you can calculate your P1 using this formula. Then P bar is the mean of P naught and P1. So if your P naught is 10 and P bar, P1, and P1 is 10 or is 20. Let's say P naught is 10, P1 is 20. Then your P bar will be equal to 10 plus 20 over 2, which is 30 over 2, which is 15%. That will be your P bar. Then R is the ratio of cases to controls, and it's usually 1 if you are using equal cases and equal controls. For example, you have 20 cases, 20 controls. Then it means the ratio is 1:1. So it means the ratio is what? Is 1. If you are using a different ratio, then your ratio will be used as appropriate. It will be used as appropriate. So that is the formula for case control study if the outcome is qualitative. Then if the outcome is quantitative, this is the formula for case control study. N is equal to R plus 1 over R into Z alpha plus Z beta squared times lambda square all over D square. While Z alpha and Z beta, the same as we have discussed earlier. Lambda is the standard deviation of variable from a previous study. So the variable that you are using, that you want to measure the outcome variable in previous study, that is the standard, its standard deviation, that is lambda. Then D is the minimum difference in the mean of both groups considered to be significant. So the minimum difference between the mean of both groups, maybe the mean of cases and the mean of control, what is the difference between them? So that difference is our D. Then R is the ratio of cases to control, as we have said. So that is case control study. So now let's look at sample size calculation for experimental study. So in experimental study, you can have two groups, you can have one group. If the experimental study is one group, for only one group, for example, you want to use one group in order to find out the difference between their baseline data and the data after a previous certain period. For example, you want to find out the difference in knowledge among the primary healthcare workers after intervention. You want to differentiate their difference before intervention, before the health education intervention, and their difference and their knowledge after you have given them health education intervention. So for example, let's take primary healthcare workers. You want to know the difference or the effect of health education intervention among primary healthcare healthcare workers regarding malaria, their knowledge of malaria. So initially, you now come, before you start the study, you now select your study, one group, only one group, you select your sample. When you select your sample, before you give them health education about malaria, you now measure their knowledge. What is their knowledge of malaria before you give them health education? You find out their knowledge is very poor at baseline without health education. They have very poor knowledge of malaria. Because of that, you now give them health education. You educate them on malaria. What is malaria? What organism is causing the malaria? What are the causes of malaria? What are the factors that can lead to malaria? What are the preventive aspects? What are the treatment? What is the treatment? What is the investigation? You now educate them adequately. So after you now educate them, you measure their health education, you measure their level of knowledge again. So you now want to compare their knowledge before you give them health education and their knowledge after you have given them health education. So that type of experimental research is called a one-group experimental study. So these are one-group experimental studies, but not two groups. Here you don't have two groups, you only have one group, but you want to measure the before you want to have a measurement, their measurement before and after intervention. That is one group study. So if you are dealing with such studies, this is the formula you are going to use to calculate your sample size. N is equal to Z alpha times the square root of P naught into 1 minus P naught plus Z alpha into the square root of P1, 1 minus P1 squared divided by P1 minus P naught squared. So this is for what? This is for qualitative values. If you are using qualitative outcome, that is, you want to measure the outcome in quality, that is in category, where Z alpha and Z beta, as we have discussed, then P naught is the null hypothesis proportion. That is, there is no increase is expected, which means that the proportion will remain as obtained at baseline. So whatever the proportion you have gotten at baseline, that is your P naught. If at baseline, you find out from our example, maybe when you measure their knowledge at baseline, you find that they have 20% knowledge. Their prevalence, their knowledge level is only 20%. So that 20% will be your P naught. While P1 is the alternate hypothesis proportion. That is baseline proportion plus expected proportion of change or expected increase or decrease. So here, if your P naught is 20%, but you expect a 20% increase after a health education, after giving the health education, then your P1 will be equal to what? 20 plus 20. That is 20 at baseline plus 20 that you are expecting to increase after health education, which is 40%. Then if you are expecting it to reduce also, you still use the decrease formula. That is, if you have a baseline at 20, but you expect it to reduce by 10, you have to have a 10% reduction, it means your P1 will be 10. That is 20 minus 10, which is 10. So this is P1. Then, yes, that is the formula for sample size calculation in experimental studies for one group. Then, if it is one group, but quantitative variable. That one, the previous one was one group qualitative variable. But now, if you have one group quantitative variable, then your formula will be n equal to Z alpha plus Z beta squared times lambda squared all over D squared, where Z alpha and Z beta, as stated before, lambda is the standard deviation of variable under study in a previous study among similar subjects. So the standard deviation of the change at baseline. Then D is the difference in mean variable considered to be significant. So what is this difference that you think will be a significant difference between the two between the two measurements after you have given your intervention? So the next one, sample size calculation for experimental study for two groups. Now, if you have two groups, group 1 and group 2, group 1 or study group and control group, but an experimental study or an interventional study. So in that case, the minimum sample size, if it is qualitative variable, the minimum sample size would be equal to 2 into Z alpha plus Z beta squared times P bar into 1 minus P bar divided by D squared, where Z alpha and Z beta, as we have mentioned earlier, then P bar is the mean proportion of factor under study. That is P1 plus P2 all over 2. And we know P1 is the prevalence of factor under study as observed in a previous study at baseline, while P2 is the projected proportion post-intervention based on the proposed hypothesis. Then D is the difference between pre and post-intervention proportion. So if you have P1, which is prevalence of the prevalence of the factor here, let's say the prevalence of the hypertension. Here, if you have two groups, group 1 and group 2. So P1 is the prevalence of factor under study as observed in previous study at baseline. What was the prevalence at baseline in the previous study? Then P2, the projected proportion post-intervention. So post-intervention, what is the proposed proportion to be increased? With how many percent do you project it to be increased? That is, this is being the size of the effect considered to be significant by the researcher. So if you are projecting it to increase by 20%, then you use P2 as 20%. Then D is the difference between the P2 and P1. So if you are saying P2 will be 20% and P1 is 10%, then your difference will be 20 minus 10, which is 10%. So that is sample size calculation for two groups quantitative variables. Then two group qualitative variables. No, quantitative, I mean, that one is qualitative. Then this one quantitative. So for quantitative variable, N is equal to Z alpha plus Z beta square times standard deviation 1 square plus standard deviation 2 square all over D square, where Z alpha and Z beta, as discussed, lambda square standard deviation of the variable under study among experimental group at baseline in previous study, while lambda 2 is the standard deviation of variable under study among control group at baseline in previous study. And D is the difference considered to be significant, as we have discussed. So that is the sample size determination. These are the different formulae that you can apply for different design, different study designs in order to calculate your sample size determination. I have not included the formula for cohort study because cohort study are not usually possible for part 2 work, because cohort study are studies that require time. They are usually conducted in maybe within a large period of time, like 10 years, 5 years, except if you are using cohort study of the historical cohorts. But this this is not usually done. But for cohort study, mostly they take a long period of time before they are conducted. That's why I've not included them, their formula here. So let's now continue with the sampling technique. When you conduct research about a group of people, so now, after calculating your sample size, the next thing is to do what? To select these people that you have calculated, this number that you have calculated. Let's say my sample size is, I have calculated 20, the sample size is 200. So now sampling technique now is, how am I going to select these samples, these 200, from my population. So that is what we call sampling technique, the method of selecting sample, the number of sample size that you have calculated. So there are usually two methods of sample size sampling technique. One is the probability sampling technique and non-probability sampling technique. Let's start with the probability sampling technique. So probability sampling means that every member of the population has a chance of being selected. It is mainly used in quantitative research. So quantitative research is a research that is conducted using this our usual research, not a qualitative. A qualitative is one that you use focus group discussion, you use in-depth interview, key informants interview, observations, and other form of qualitative research. Those are the qualitative, that is the qualitative research. That's focus group discussion, interviews, key informant interview, and other forms. But our research that we usually do in this aspect, in this our part 2 work and other works here, is usually quantitative research. But some of us are combining the two, quantitative and qualitative researches, but mostly quantitative research. That is what we use in order to calculate our sample size. If you are conducting a qualitative research, you don't need to calculate any sample size. You just state how many interview you want to conduct, how many focus group discussion you want to conduct, and that's all. But here you have to calculate the minimum sample size and then select your sample size accordingly in such a way that it is a representative of your population. So now the best method of sample size or sampling technique is the probability sampling technique, because probability sampling technique has given an equal chance for everybody in that population of being selected. So it means whatever you select from the using sample size, using probability sample size, you are surely selecting a representative of that population. So that is the best sampling technique you can do. So this probability sampling technique is also of different types. There are different types of probability sampling technique. One, we have simple random sampling. Two, we have systematic sampling technique. We have stratified sampling technique. We have cluster sampling and also multi-stage sampling technique. So simple random sampling is a type of sampling technique that every member of the population has an equal chance of being selected. How do you conduct simple random sampling? Maybe you have calculated your sample size to be 90. So you want to select 90 people from this population. But in your population, you have maybe more than 90, you have 150 people in the population. But you want to select 90 out of them, and you want to use simple random sampling. How do you go about it? You can just use a computer probability sampling, a computer random selection uses computer. So how? You can give the general population, maybe they are 150. You can give them number from 1 to 150. So everyone selects a number. So you have given the number to from number 1 to number 150. So out of this, you want to select 90 people. You can just put it in the computer to do a random selection for you. So the computer will select 90% randomly. Then you now find out who are the people computer selected. Then computer, you can find out maybe computer select number 1, number 10, number 13, number 50, number 41, number 63, number 23, number 38, number 46, number 91, number 104. So that is how you see computer will just randomly select 90 for you. So your own is just to have the list and come to the population. Who is number 1? Come. Then administer questionnaire for him. Who is number 10? I'm number 10. Okay, you are included. Who is number 14? I'm here. Who is number 58? I'm here. Who is number 33? I'm here. So that is how you now select it randomly without any bias. It means every member of that population has an equal chance of being selected. That's all. So that is simple random sampling. You can also use simple random sampling by balloting. How do you ballot? You now, maybe there are 150. You now come and use a small paper and write you now select 150 paper, small number. Out of them, you put yes to the 90. You want to select 90. So out of this 150 small paper that you have cut, then you write yes for in the 90 of them, and the remaining you write no. Then you squeeze them and reshuffle and put in a basket or in a plate, and now call all the population all the members of this population to come and pick each of the population member come and pick one paper. So anybody that picked yes will be selected. Anybody that didn't pick no will not be selected. So that is simple random sampling by balloting. So that is how you now give every equal member equal chance of being selected. So this is called simple random sampling. Then another method of probability sampling is systematic sampling. In systematic sampling, there are two things you need to know in this case. You must have a sampling frame and you must calculate a sampling interval or sampling fraction. So what is sampling frame? Sampling frame is the total number of all the population. For example, in a clinic, that clinic, the number of people in that clinic, they are 140 or they are 100 people. That is the population, total population in that clinic. So it means your sampling frame is 100 because the total population is 100. So this your sampling frame, you have to have the list of this sampling frame. So the list of every member of that population, all the patients in that clinic, they are in one list and they are listed from number 1 to number 100. Or even if you don't have the list, but you anticipate maybe in the clinic from so period to so period that you are going to collect your data, you anticipate a total of 100 people to come as your sampling frame. So out of this sampling frame, you want to select, let's say our sample size is 40. You want to select 40 out of this 100, which is your sampling frame. So for you to select 40, you have to calculate what we call sampling fraction or sampling interval. Sampling fraction is equal to sampling frame or sampling frame sampling interval, sample size, your sample size divide by sampling frame. That is sampling fraction. But if we want to calculate sampling interval, so sampling interval will be equal to what? Sampling frame divided by sample size. So let's say our sample size is 40, or let's say it's 20, to make it simple so that we know how to do it. So if our sample size is 20 and our sampling frame is 100, we are going to select 20 people out of 100 people that will come into the clinic within the period of our data collection. So how do we calculate sampling interval? Sampling interval will be equal to our sampling frame, which is 100, divided by our sample size, which is 20. So 100 divided by 20 will be equal to what? 5. Will be equal to 5. So our sampling interval will be equal to 5. So you are going to use this 5 to select your members. So the number one person, the first person to be selected, you have to use simple random sampling to select the first person out from these 5. So you select, you say from number 1, number 2, number 3, and number 4 and number 5. Because your sampling frame is 5. So you have the first 5 people. From the first 5 people, you have to use simple random sampling to select one of them. So if you select one of them, the other people you have to select them as every 5th person. Every 5th person will be selected. So if you select number 3 in the first sample random sampling, out of these 5, the first 5 people, you now say, okay, let me squeeze small paper for them. So I will have 5 small paper, and 5 I'll write yes in only one. The other 4 I'll write no, and then squeeze them and spread to them. Let them select. Each one of them should select. So out of these 5 people, let's say number 3 selected yes, and other number 1, number 2, number 4, number 5, they all selected no. So all of them will go, and number 3 will be interviewed and will be selected. So then the next person to be selected is the 5th person from the 3. So if we saw number 3 is selected first, the next person will be what? Number 8 from our sampling fraction. From our sampling frame, number 8. So if number 8 is selected now, then the next one will be what? Number 13, which is the 5th person. From number 13, the next person will be number 18th. From the number 18th, the next person will be number 23rd. That is how you will be selecting them until you select all your 20 people. So once you select your 20, then you are good to go. So that is what we call systematic sampling technique. So even if you are using, you are selecting them from the clinic, since in the clinic, you know all their numbers. Anybody that come, you just collide with you just use the record officer. Okay, please, I want any person that comes, if number kaza come, tell me. So if you are selecting number 8, next one, and number 8 didn't come, you just tell the record officer, once number 8 comes, please let me know. So the record officer, once number 8 comes, he will tell you, okay, this is number 8. Then you now select him. Then you wait for number 13, and then wait for number 23rd, like that, up to the end of until you get all your numbers. So that is what we call systematic sampling technique. Then the next one is what? The next one is, okay, this one I have all explained them. Next method is stratified sampling technique. Stratified sampling technique is a sampling technique that is done according to stratum. But here, you will combine, after you using a stratified, you have to combine two probability methods for this technique, more than one probability method. Because stratified sampling, the first thing that you do, you stratify your sample according to different strata. For example, you are conducting a study among healthcare workers. So you know healthcare workers, they are of different strata. You can have doctors, you can have nurses, you can have pharmacists, you can have lab technicians, lab scientists, and what have you. So you can say you are going to use a stratified sampling technique. The first thing that you do in stratified sampling technique, you have to stratify your sampling according to stratum, according to different strata. The different strata is based on their cadre. It means you have doctors' data, which is a different stratum for them, one single stratum for them. You have nursing stratum, you have pharmacy stratum, you have lab scientist stratum. So in case, for example, you have 4 stratum: doctor stratum, nurses stratum, pharmacy stratum, and lab scientist stratum. So you see, you have divide your sample size, sample according to 4 stratum. So each stratum, you have to calculate, you have to proportionately allocate your sample size according to each of the stratum, based on the number, their total number. How? For example, doctors, let's say doctors, they are 100 in total. Nurses, they are 200 in total. Pharmacists, they are 50 in total. Lab scientists, they are 70 in total. So when you add doctors stratum, doctors, they are 100. Nurses, 200, making 300. Pharmacists, they are 50, making 350. Then lab scientists, let's say they are 50 also, making 400. So all the population, your general population, they are 400. But according to their own stratum, each stratum has their own total number. So now out of this 400, you want to select 100 people from all the stratum generally. So how do you allocate the number for doctors, number for nurses, number for pharmacists, number for lab scientists out of this 100 that you are going to select? You have to allocate this 100 according to each and every stratum. So how do you do that? You now say, okay, the number to be selected for doctors will be equal to, doctors, they are 100. So it will be equal to 100, that is their number, divide by 400, which is the total number of everything, times sample size. So your sample size will be equal to what? Our sample size is equal to 100. So now for doctors, their number to be selected will be equal to 100, which is their total number, divided by 400, which is the total number of all the population, all the cadre, then times 100, which is the sample size. What will it give you? So let's calculate it. So 100 divided by 400 times 100. will be equal to 25. It means you are going to select 25 doctors from this 100. Then from there, go to nurses. Nurses, they are 200. And still you want to select, you want to give them their own quota. How do you go about it? So for nurses, you say nurses, which are, because they are 200, you say 200 divided by 400, which is the total, times sample size, which is 100. So it will be equal to 200 divided by 400 is equal to 200 divided by 400 is equal to what? 200 by 400, 0.5 times 100, which is sample size, 50. So you are going to select 50 nurses. So you see, that is how you allocate, you proportionately allocate the sample size for each and every strata that you have stratified. So now from here, you see, we will have 20 doctors, 50 nurses, 25 doctors, 50 nurses, 17 pharmacists, 17 or 18 lab scientists. So from there, you now use another method of data collection, method of sample size estimation to select from each of the cadre. For example, we say we want to select 25 from doctors. So here you can apply either systematic random sampling or simple random sampling to select 25 doctors. Then you go to nurses. You can also apply either simple random sampling or systematic sampling to select your nurses, your 50 nurses. You go to lab scientists. You apply either simple random sampling or systematic sampling technique to select your lab scientists. You go to pharmacy and do the same thing. So that is how you go ahead, how you do stratified sampling technique. Then next one is what? Next one is cluster sampling technique. So cluster sampling technique is similar, somehow similar to stratified, but here is usually done if in field studies. Field studies, when you have different villages as a cluster, different villages, you now take a village to be a cluster or a group of villages to be a cluster. You now say, okay, I'm selecting 1,000 people in each and every cluster. So you now identify certain characteristics to be the cluster. So let's say we are identifying the cluster as villages that are close to each other and share similar characteristics. So you now say the cluster 1 contains village 1 to 5. Cluster 2 contains this to this. So cluster 3, that's now how you do now your cluster. So when you have your cluster, you then apply either simple random sampling or systematic sampling technique to select your sample from each and every cluster, as we have said in the stratified sampling technique. But for cluster technique, if you calculate sample size of 200, because of the effect of cluster, you have to times it by 2 because of the cluster effect. So you have to times the sample size by 2 to avoid correct for cluster effect. So now their sample technique, because the cluster will be doubling your calculated sample size, and you now apply it and spread it according to the cluster, and then use either simple random sampling or systematic sampling to select your respondent in each and every cluster. Then multi-stage sampling. So multi-stage sampling, you see, probability sampling is mostly these two types, the first two that we have said, either simple random sampling or systematic random sampling, because the other three, even if you apply them, you must apply one of these two in order to select the participant. Even if you are using stratified, or you are using cluster, or you are using multi-stage, at the end of the day, you must apply either simple random sampling or systematic sampling to actually select the respondents you want to include. Please, there is somebody's sound is not muted. Please, if you know you have not muted yourself, please mute yourself so that we should not have background noise. Thank you. So now, for multi-stage sampling, if the type of sampling that you do when you have different stages, when you want to make a sampling from at different stages, if you want to sample at different stages, like let's say we want to conduct a study in Sokoto State that will generalize Sokoto State generally. So you see, the first thing you have to now select from the senatorial zones, select the LGS, select the ward. From the ward, you select the health facility. From the health facility, you go to the down up to the participants. So there are different levels of selection. Let's say you want to conduct a study, prevalence of malaria in Sokoto State, prevalence of hypertension in Sokoto State. So how do we go about the sampling technique? So we say we can use multi-stage sampling technique in order to select our participants. Stage one is the selection of LGS from the senatorial zones. You see, we have 3 senatorial zones, or we say selection of senatorial zones. Then stage 2, selection of LGS from the senatorial zones. So stage 1, selection of senatorial zones. Let's say we select all the senatorial zones, 3 senatorial zones. Here, there will be no probability. We can say all the senatorial zones were selected. Then stage 2, selection of LGS from each and every senatorial zones. We can say 3 LGS will be selected from each of the senatorial zones. So senatorial zone 1, let's say Sokoto South senatorial zones, they have 7 LGS. So from there, we select 3 LGS. So Sokoto Central senatorial zone have 7 LGA, we select 3. Sokoto North senatorial zone or Sokoto East senatorial zone, we select 3 LGS. So you see, at the end of the day, we will select 9 LGS from each, 3 from each and every senatorial zones. So how do we select it? So the 9 LGS, we say simple random sampling will be used to select 3 LGS from each and every senatorial zones of Sokoto State. So you see, senatorial zone 1, which is Sokoto South, has 7 LGS. We can now do balloting to select 3 out of the 7. Then we go to Sokoto Central, we do balloting to select 3 of the 7. Then we go to Sokoto East senatorial zone and do balloting to select 3 senatorial zones. So that is stage 2. Then stage 3 is the selection of wards from the selected LGS. You can say 3 wards will be selected from each and every selected LGS. Now, so now from Sokoto South, we selected Sokoto, from Sokoto Central, we selected Sokoto South, Kware, and Wamako, local governments. So now the stage 3 is the selection of words, political words. So now 3 political words will be selected from each of the selected LGS using simple random sampling by balloting. Then you do balloting to select 3 words from each of the selected LGS. That is your stage 3. Then stage 4, selection of health facilities. So from each of the wards, 1 health facility will be selected. 1 primary healthcare facility will be selected from each ward. So you see, that is how you go about it. So now you select 1 health facility in the ward. So in that health facility, how do you select your participant? Then at the end of the day, you say stage 5, selection of study participants. So here you can use either simple random sampling, you can use either systematic sampling to select your participant at the grassroots in the health facility that you are going to select your study participants. So that is how you go about it. That is what we call systematic or multi-stage sampling technique. You can also do multi-stage sampling technique in the university study. Because university, you see, in a university, there are different stages. Number 1, maybe selection of faculties. Maybe a university has 20 faculties. Out of these 20 faculties, in stage 1, we are going to select 10 faculties. Then stage 2, selection of departments. So in the faculty now, you come to the faculty, all the selected faculty, how many departments are you going to select? You now use simple random sampling to select your departments, to select maybe 3 departments or 2 departments, depending on your own, depending on your capability and your resources. So nobody will ask you to select so number of a certain number of department or certain number. You are the one that will look at your own capacity. You look at your own resources and financial whatever. You look at it and then say you are going to select either 3 or 2 or 1, even 1, based on your own capabilities. So you now say you are, after selecting 10 faculties or 3 faculties, you now say, okay, from each of the faculty, I will select 3 departments using simple random sampling. Then from department, you now say, I will select classrooms or classes. These are the classes that I'm going to select. Then from the classes, then selection of what? Selection of participants. Then you now use either systematic random sampling or simple random sampling to select your participant in the classroom. So that is how you conduct multi-stage sampling technique. So these are the probability sampling methods. Now let's look at non-probability sampling methods. So you see, non-probability sampling methods, they have their problems. Their best problem or most important problem is that generalizability. You cannot use non-probability sampling to generalize your results, because whatever you have selected is not a representative of that population. Because non-probability sampling. Please mute yourself, please. Somebody has spoken and the background sound is being heard. Please mute yourself. Thank you. So non-probability sampling are usually not good in generalizability. So once somebody uses it in their research, that research will not have an external validity. The external validity will not be there because you cannot use non-probability sampling and generalize it to other members of the population. So there are different non-probability sampling techniques. Number 1, we can say consecutive sampling. convenience sampling, voluntary response sampling, purposive sampling, snowballing sampling, quarter sampling. So consecutive sampling. Consecutive sampling is also known as total enumerative sampling. In this case, you only sit down in the clinic. For example, you only sit down in the clinic. Anybody that comes, you include him. Anybody that comes, any case that you think you are interested in, you will include him until your sample size is reached. So that one is not a probability. It's not a probability sampling. Other people that may have come later were not given a chance of being selected in that society. So you are only after anybody, first come, first serve. So this one is not a probability sampling, and it can introduce a bias, and it will not be used to generalize the study findings in that study. So then convenience sampling. Convenience sampling is the type of non-probability sampling that you do according to your convenience. Maybe anybody that you think will cooperate 100% with you, you just go direct and interview him and include him in the study. Anybody that you think will give you some little headache, you will just forget about them and go direct as convenient as you want. So you do it at your convenience. You select the members at your convenience. That is convenience sampling technique. And this one is also non-probability. You cannot use it and generalize the research result to the general population. It introduced different sorts of bias, like selection bias, sampling bias, and also it will not have an external validity. Then voluntary response sampling. Voluntary response sampling, maybe you just come to the clinic, just asking, do you, anybody that agree? You don't know anybody that can volunteer to come and be included in this study should come. So you see, it's just voluntary. If I volunteer, if I don't volunteer, I'll just go away. So that is not. It's also similar to convenience sampling. Voluntary responses. Anybody that chooses to respond to this will respond. Those that choose not to respond will not respond. In this case, most of the people, higher rank people, will just choose to not volunteer. People that are in different market population will just go to their market and leave you. You will end up with only people that are there, that are at home at the time. So it means your results or your findings will only be used for such population that you have conducted your research on, not the general population. So that is voluntary. Then purposive sampling. You are selecting your sample based on purpose. Let me just go. Is he my friend? Because he is my friend, let me include him. This one is the friend to my wife. Let me include her. This one is so. Because of your own purpose, you are just selecting them according to purpose. So that one is not also a probability sampling, and it has a very problematic ending. Then snowballing. Snowballing non-probability sampling is when you are using some members of the research to lead you to another member. For example, if you are studying some confidential research topics, you are studying on a confidential research topic or an area that is confidential, like maybe you want to you are studying among commercial sex workers and you don't know how to get them. So you just find someone that knows them. Or you just find one of them by chance. You just got to find one of them. So from that person, the person, you can ask him to lead you to his friends that are doing the same issue, that are doing the same business. So he will lead you to another person, and that person will lead you to another until you reach all of them. You reach all of them. So that is snowballing. You use some people in order to reach out to other people. So that is snowballing. That is also not a probability sampling. It's just non-probability, and it has its own problem. Then another one is quarter sampling. Quarter sampling is also the non-probability version of stratified sampling. You just stratify them, group them according to different quarter, as we have said in the stratified sampling technique. You classify them according to quarter. Each quarter, you just use your either consecutive sampling or convenience sampling or voluntary sampling to select them. So that is quarter sampling. It is also a non-probability sampling. So let's look at correction factors for the sample size determination. As we have said, correction formula, if the population is finite. For the finite population, the correction factor, okay, I think the formula is missing here. Let me read it for you. Maybe you can write so that we discuss it. And I think that is the last aspect of this presentation. So the formula NF is equal to small n divided by 1 plus small n over capital N. I will take it again. NF, finite population, is equal to small n all over 1 plus small n over capital N. I will repeat again. NF, that is finite population, is equal to small n all over 1 plus small n over capital N, where NF is the desired sample size when study population is less than 10,000. So now, if you are conducting a hospital study where the study population is usually less than 10,000, after you use that formula that we have discussed in all the sample size determination formulae, all of the formula, anyone that you have used, after using that, sometimes you may see that your sample size that you have calculated is even more than the study population that you are dealing with. So when you see that, don't worry. You are on the right track. The only thing that you are going to use is to use this correction formula. So the correction formula here says NF, which is desired sample size when the study is less than 10,000, will be equal to small n. That small n is the n that you have calculated in the previous formula. So if your previous formula, you calculated 300, you got 300. So your small n will be equal to 300. So it will be equal to 300 all over 1 plus 300 divided by capital N. And your capital N is the average population, average size of your population now that you are going to select from. So if you are going to select your sample from 100 population in the clinic that you anticipate to be selected to be involved in this study, or to be the population of this study, maybe the pregnant women attending ANC in UDUTH, all of them, averagely, they are 100. So your capital N will be equal to 100. So in this case, your corrected formula will be equal to NF will be equal to 300 divided by 1 plus 100 divided by 300. So 100 divided by 300 will be equal to what? 100 divided by 300 will be equal to 0.33. So it will be equal to now 300 divided by 1 plus 0.333. So your NF will be now equal to 300 divided by 1 plus 33, which is 1.333. So when you now divide it, what are you going to get? 300 divided by 1.333, which is 225. So that is how you now correct the formula, how you correct your formula. So with this, I think we have come to the end of okay. Now non-response formula or attrition formula. After correction for finite population, the next thing is to do what? To calculate for non-response. So any study that is either cross-sectional or comparative cross-sectional case control cohort study, you use non-response or you use attrition rate. So attrition rate is usually from the cohort study or experimental study. Maybe you start with 200 people, but in the course of the study, 5 of them, they have done attrition. Maybe they have pulled out of the study due to some problems or definite or just like that. So you now correct for attrition. And how do you correct for attrition? NS, that is the overall sample size will be equal to N over 0.9. If your response rate is 90%, you are anticipating 90% of all the participants to respond correctly, then that is 10% attrition rate. So if you are using 10% attrition rate, this is how you correct for non-response. That is, NS will be equal to N over 0.9. So if you have gotten your N to be 300, so you are correcting for non-response of 10% or 95% response rate, then you use 300 divided by 0.9. Then whatever you get is the final population sample size you have determined, and that is what you will use for your study. Thank you very much for listening. And now we entertain question, observation, and comments. Thank you very much.
Thank you so much, sir, for the okay, sir. Thank you so much, sir, for the elaborate lecture. We really appreciate it. It's a very good learning point. So we'll entertain questions and comments from the participants. I'll start by reading the questions on the chat box. Anybody with a question can either text it on the chat box or indicate by raising hand. So we allow them to unmute and talk. Okay, the first question on the chat box is from Dr. Mahmoud. He said, please, I want clarification on sample size reduction formula.
Okay. So I have stated it like 3 times so that we will not miss it. So okay, the sample size formula that you are going to use to reduce their sample size when the samples, if your population is less than 10,000, is equal to n, small n, divided by 1 plus small n over capital N. So here, small n is the sample size that you have calculated using the formula Z square PQ over D square, or any formula that you have used. whichever formula you use in the calculation is called formula for calculating population sample when the population is above 10,000. So now that n, whatever you calculate from the formula, that is the n, small n. Then capital N is the average number of your population over the period of your data collection. If you are going to conduct your data collection over 1 year, then average population of your study participant in 1 year. For example, most research part 2 research, they should be conducted in 1 year. So now, if your study population is pregnant women attending UDUTH in Sokoto, so now your capital N will be the total number of pregnant women, average number of pregnant women that attend UDUTH in 1 year, over 1 year. So that is your capital N. So that capital N, whatever the sample size you will get must not be more than that capital N, because you are going to select from that capital N. So if your sample size is more than capital N, then it means that one is not possible. So that is why you must have a correction formula, and that is the formula you are going to use. Thank you. So any other question?
Okay, thank you so much, sir. The next question is coming from Dr. William Akinyemi. So thank you so much, sir, for the presentation. That his question is, what will be the appropriate sample size determination for a study to determine the effect of BMI on early functional outcome following total knee replacement?
So that one is an experimental study.
That the question is, yes, sir.
Yes, it's experimental study. So just
Okay,
look at the formula for experimental study. If you are using one group, look at the one experimental study, one group. And if you are using 2 groups, use the formula for 2 groups. But that effect, unless if you are the one that will now introduce the intervention. But if you are just measuring them, and from the measurement you now test the effect, then that is not an experimental study. Rather, is a comparative cross-sectional study. If one group is a cross-sectional study. So thank you. Just go to the formula. Make sure that your study design is known. Once you know your study design, then select the formula appropriately, as we have discussed earlier. Thank you.
Yeah, thank you so much, sir. This Samuel Richard is saying, thank you for the presentation. Please, how do we get sample size from for retrospective cohort qualitative study? I think this one has been addressed. Then he's also saying, is the sample size calculation for experimental animal study same for humans?
Yes, it's the same. It's the same. Sample size calculation. The only thing, you just look at your study design. That's all.
Okay, sir.
But whether it's from animal or human, the sampling, the formula will be the same. The only thing that you will look at the formula, you have to look at the design, the quantity, the outcome variable. That's the 2 main things that you are going to look at in selecting the formula.
Okay, thank you, sir. Dr. Henry is saying a very interesting lecture. Thank you, sir. Dr. Ipan, masterpiece. God bless you, sir. Dr. Amina Lawan Umar. Thank you, sir. Please kindly explain non-response correction.
Okay. Non-response, you see, in some researches, especially cross-sectional studies, you see, cross-sectional study, there is no room for attrition. Attrition is when you start the study with someone, and before you reach to the end of the study, he pull out, or some of them pull out and leave the study. Maybe because they have traveled, some have died. So you started with them, but before the end of the study, they have died, some have relocated. So those ones, they are the attrition. So you can correct for attrition. After calculating your sample size at the end of the day, you can say, I will add 10% attrition rate. In case 10% of my people, of the people I have started study, in case 10% of them leave the study from one reason or the other, I have already corrected for them. So that is why when you correct with that, you make that correction, it means you are adding 10% of your total sample size into your sample size. For example, you calculate 100 people as your sample size. So when you add attrition rate of 10%, it will now reach to 110. So you see, even if 10% people have dropped out of the study, you still have your initial 100 people. So that's it has taken care, that attrition rate has taken care of those people that have pulled out of the study. So the same thing as response rate. Now, in cross-sectional study, maybe you selected 100 people, and your sample size calculation, you calculated optimum sample size of 100 people. But when you give these 100 people your questionnaire, one person did not complete the questionnaire. He only maybe wrote, he didn't answer some questions, he answered some questions and didn't answer some questions. You see, there is poor response there. Another one didn't complete the questionnaire. When you want to analyze, you find many people have not responded to very important questions. So in this case, you need to remove those people. So that is why you have to correct for that. You have to anticipate that in case you have such type of people that will not respond, that will not have a full response to your questions, you have already corrected for them at the level of sample size. So you say you anticipate 90% response rate. So in case you have 90% response rate, you have already taken care of this 10%, and you have added them to your study, to your sample size number. So in case of, instead of 100 people that you initially calculated, when you add the effect of 90% response rate, you will add 10% to that. It will now be 110. So that in case during the analysis, you found those people that have not responded very well to your question, you just discard them away because you have already taken care of all of them. So that is the importance of this response formula, attrition formula or non-response formula. And we say how do you collect, how do you respond to it? Whatever you calculate, divide by 0.9. That is all. So if your sample size is 100 and you want to add 10% non-response rate, just say 100 divided by 0.9. 100 divided by 0.9. It will give you 111. So you see, you are now new general sample size will be 111, including the non-response rate. So even again, if you are using experimental study, you are anticipating 10% attrition rate. Once you include, you add 100 with 10% attrition, it will still be 111. So you see, you have corrected for non-response. In case after the study, some of them pull out of the study, or some of them didn't have a good response, you have already corrected. You can just leave them and discuss them. Thank you very much. That's the issue.
Thank you so much, sir. This understand. Thank you, sir, for the lecture. Please, I want clarification on the formula for comparative cross-sectional study with quantitative variables.
Yes. So for comparative study with quantitative variable, look at this formula. I have explained it very well. So let's go back to it. Yeah, for quantitative variable comparative cross-sectional, we said N is equal to Z alpha plus Z beta squared times lambda squared, that is standard deviation squared over D squared. We said Z alpha and Z beta, they are all constant. Z alpha is usually equal to 1.96. Z beta is 0.84. So that one, there is no problem. Standard deviation square, that standard deviation, that lambda, is the standard deviation of one of the groups. If you have two groups, group 1 and group 2 in previous study, the standard, you have to find the standard deviation in group 1 and standard deviation in group 2 in previous study. Then which one are you going to use? We said the higher standard deviation of the two. So you see in group 1, let's say their standard deviation was 35.2. In group 2, the standard deviation was 20.5. So this standard deviation that you are going to use is that of group 1, which is 25. That is better or higher than the group 1. Then D is the difference, is the difference considered to be significant between the two. If you think 20% difference will be significant between the two, will be a significant difference between the two, then your D will be 20. No, not 20%. It is in number. If maybe based on what you are calculating, if you are calculating maybe PCV, you are using PCV. Maybe group 1 has a PCV of 20%. Group 2 has a PCV of 25%. You think a difference of PCV of 10% or 5% is enough to be a difference between two groups, then use 5% as your D. If you think 10 can be a significant difference, then use 10. This one is based on your research and understanding of these values. Then that is how you select your D. So that is the explanation of this formula. Thanks.
Thank you so much, sir, for the elaborate explanation. Next question is from Dr. Cynthia. She's saying that, thank you, sir, for the lecture. If my sample size is 50 and I'm to get my data over 1 year, do I continue to collect data if I exceed 50 in 4 months? In 4 months? Thank you, sir.
No, it means you have not spread, you have not done a good probability sampling in that case. Because if you have done a good probability sampling, you cannot take your data that you anticipate to take within 1 year, you cannot take it in 4 months. Because you are going to take everything into consideration. One, how many patients am I expecting on every clinic day? So how many clinic days am I going to go for data collection? So you have to consider all these things. If you are going to select 100 people over 1 year, so over this year, how many clinic days am I supposed to attend and take my select my sample? Maybe out of in this 1 year, we are going to utilize 40 clinic days or 10 clinic days. So in this case, on every clinic day, you have to spread on every clinic day, how many people am I going to select? Based on the number I'm going to select and based on the general population of the people that come on every clinic day. So let's say on every clinic day, I'm going to select 3 people. So you see, You have to spread that. It means even if you reach up to 4 months, you cannot select everybody, because you have already considered all the clinic days in the year. So that is it. You have to consider everything. So maybe in every clinic day, I will select three people. So now, for me to select 3 people in every clinic day, how am I going to select these 3 people? Is he using simple random sampling or using systematic sampling? If it is using simple random sampling, I will anticipate maybe number of people on every clinic day. Let's say 10 people will come on every clinic day. So out of these 10 people, I'm going to select 3. So I will just use computer random sampling, random allocation to allocate these 10 people that will come on to give me the insight of which of them am I going to? Is it no? Am I going to select number 1, number 9, number 4, or number 10, number 6, number 1? That is your computer. The computer will do everything for you, and it will tell you for the 10 people that will come, that you anticipate to come on this clinic day, select number 8, number 2, and number 4. So you just sit down on the clinic day until your number to select comes. If number 1 comes, the computer says you select number 8. You will not do anything with number 1. You wait for number 8 to come. Once number 8 comes, then you select him. Then you continue waiting until the number that you're supposed to select comes. You select. You do that. You spread it to all the clinics days, and that is how you go about it, so that you avoid selecting within a shorter period of time. Thank you.
Okay. Thank you so much, sir. Dr. Mahmoud is saying, thank you very much, sir, for the elaborate lecture. Then Dr. Paul is asking, how do you apply design effect in non-probability sampling?
No, the non-probability sampling, there is no use of design effects in non-probability sampling, because you are not using any formula. So you are not using the probability sampling technique. And even if you are using the probability sampling technique, it's only in cluster sampling technique that you use cluster effect. So this one, you can use. Is it cluster effect that he said, or what?
Non-probability sampling. You just say, how
How
do you
to
apply
correct for?
design effects in non-probability sampling?
Yeah. So there is no, you can't apply design effect in non-probability sampling. Design effect is only applied in cluster sampling technique. Thank you.
Thank you so much, sir. The next question is saying that in what instances will it be feasible to use non-probability sampling and not probability sampling?
So that one is dependent on you as a researcher. You as a researcher, you will now think, this research, the findings of this research, I want to generalize it to the general population. And you see, definitely you cannot use non-probability sampling to generalize. So it depends on your own insight or on your own aspect. If you think the probability sampling method are not feasible in this research, there are some researches that is not the probability sampling is not feasible, is very difficult to use. In such case, you now use non-probability, but once you use non-probability, definitely there will not be generalizability. So that is it. But you can still use probability sampling using simple random sampling by waiting for them to come. You just give number. You anticipate so number will come. So just use the random computer random allocation to allocate the number of people. Which number are you going to include? But that one may take time. It may allocate maybe number 40 for you, But before number 40 comes, you may be coming every clinic day, number 1, number 3, number 4, up to number 40, before number 40 comes. But if you want to use non-probability, then definitely you cannot generalize the research. Thank you.
Okay, thank you so much, sir. His next question is, can simple random sampling be combined with consecutive non-probability sampling in a cross-sectional study?
No, once you do simple random sampling, it means it is no more a non-probability, because simple random sampling is a probability method. It gives everyone a chance of being selected. So once it is included, then it is no longer a non-probability. It is now a probability sampling. So don't even mention non-probability. Just say a simple random sampling was used to select participants. Then you now describe what you did, how you did it. So that is a random sampling, not a non-random sampling.
Mm-hmm. Oh, thank you so much, sir. The next question is from Dr. Abdulaziz Balarabi. He's saying, thank you for the lecture. What will be the prevalence of factor under previous study of the below study? For example, association of serum vitamin B12 and insulin resistance among patients with type 2 diabetic mellitus. Is it the vitamin B12 or insulin resistance?
No, what
Mm.
you will use, the outcome, which one is the outcome among them? If vitamin D is the outcome, then you are going to use that. So you use the outcome, not the, you use the outcome variable in selecting, in finding the factor under study, not the predictors, not the predictor or associated factors, the outcome. Anyone, if you have more than one outcome, then you get for all of them and use the one that is had the highest number. So if you have 2 outcomes, you select for the first outcome, second outcome, and now between them, which one is more than the other? You use the one that is more than the other. That's all.
Okay, thank you so much, sir. Dr. AA is saying thank you, sir, for the insightful session. Dr. Infinix saying thank you very much, sir, for the lecture. Sir, if one is doing a cross-sectional study and the sample size is 140, but the researcher recruited 151 participants, is he wrong? Are there any consequences during the college dissertation defense?
No, in this case, we cannot say it's wrong. It's wrong. But you see, in the course of the presentation, we said a very large sample size has its own effect. But adding only 20 from one, that one is not a bad thing. It will even improve the precision of the study. But how do we say it's large? It's more large that it can even affect, it can introduce type 1 error, when type 2 error, I mean, when it is, maybe it doubles, when it doubles your calculated sample size. So that one is large enough to cause a type 2 error. But this one will not have any effect for that. And I don't think the college will penalize him for that. So it will even add to the precision of the study. Thank you.
Okay, thank you, sir. This one is saying, Dr. Yusuf is saying, thank you so much, sir, for the powerful and electrifying lecture. Please, sir, I need more highlight on the implications of altering both alpha and beta in the same sample size determination. For example, taking confidence level to 99% and power to 80%.
That one, there is no, the implication is that you narrow your finding. The confidence is so narrow that you allow only 1% chance of error. So it means there may be some effects or some associations that you will miss, because you have narrow your idea that anything that is less than 1% or more than 1% will be considered not significant. So it means it will be very difficult for you to get a significant association in that research, because you have narrowed it down so narrow that you didn't give any room for other things to come in. But I think the most important one that are done is that I use is 95. When you give 95, giving 5% chance is not a bad idea. It's not a bad thing, and most of the researchers they do that. You hardly see a researcher that use 99% confidence interval. That one is too narrow. You have narrowed yourself. So, but that one is very good in the researches that are dealing with human lives. So, for example, researchers that are introducing new drugs, new interventions that will touch the lives of human beings, that maybe if they are gotten wrong, they can lead to mortality or morbidity in the population. So in such researches, it's better to narrow them down to up to 99%, so that anything that this research says is 99% sure. You have a 99% assurance that it is true. If this research says this drug is effective in the management of this, is effective in reducing this problem, then you are 99% sure. So if not because of this, in this type of research, I think 99% is so narrow. It will even, there will be no proximity in your research. It's better to use 95% in our normal researches, if not the researches that are dealing with human lives. Thank you. So any other thing, Dr. Mujtaba? Hello, Dr. Mujtaba.
Dr. Mujtaba, it seems to be offline. Good afternoon,
Okay.
sir. We really appreciate your time to deliver this lecture despite your very tight schedules. And many of the members from the various groups, they always appreciate this lecture. In fact, if you notice the participants that join from all over the country, and it's very helpful, we really appreciate. I think Dr. Mujtaba, any of the other ARD Expo? Do we have any of the other ARD UDUTH Expo, like the secretary or vice?
So my hand is up. Can I ask a question now?
Okay,
yes,
Oscar, please.
Okay, thank you very much, Prof. I'm so happy about your presentations, and everything was made in a simple language for us. God bless you. But my question has to do with experimental calculations, where we have the P1 and the P0. For instance, my study has to do with prevalence of malaria. I'm reducing it from 53% downward. Now with the P0, which I think I'll have to use about 15% reduction. Should I use that 15% based on assumption, or I should use it based on research? If it is based on assumption, can these assumptions withstand thesis defense? Thank you very much.
Yes, you can, but it's better if you have a previous study, you have a study backing of to it is better. But if you don't have any backing for it, you can just assume that this will be significant reduction for me and use it. Nobody will penalize you for that.
Thank you very much, sir.
Yes. So I think, is there any other one that we want to speak, or we call it a day? So without any other thing, I think we say goodbye to all of us and thank you for the participation. We see next
Thank you,
week.
sir.
Yeah.
Okay, sir. Thank you very much. So the lecture for this series will not hold for tomorrow, 4:30, right? You are through with
Yes.
all the lectures
Yeah,
for today.
we are through for the lecture, for tomorrow's lecture.
Okay, so on behalf of the ARD and on behalf of the ARD UDUTH, who is not online due to maybe network reasons, we'd like to really appreciate our resource person for taking his time to deliver this lecture. We look forward to the next series of lectures. God bless you, sir. Thank you.
Yeah, thank you very much. God bless all of us and have a nice day. Yeah.
Thank you, sir.
God bless you abundantly, sir, and God bless you, ARD executives.
Thank you very much.
Thank you, sir. Thank you.
Thank you, sir.
Yes, thank you.
Thank you, sir.
Thank you, sir.
Sir,
Thank you, sir.
Yes, you
Thank
are
you.
all welcome.
some of us are joining from Ibadan. Please, when is the next meeting?
Can somebody share maybe on the chat box